everyone, and welcome. Have you ever felt like there's a secret world hidden beneath the surface of things? Like there are codes to be cracked and mysteries just waiting to be solved? Well, that's exactly what we're here to do today. Only our secret world is the wonderful world of mathematics. We often think of maths as this rigid set of rules, something we learn at school, and then promptly try to forget. But I'm here to tell you, maths is so much more than that. It's full of surprises, hidden patterns, and frankly mind-blowing concepts that will change the way you see the world around you. Today, we'll explore 3 unique math concepts that are rarely taught but incredibly fascinating. Get ready to see math in a whole new light. Let's start with something I call the echo line. Now, imagine listening to your favorite song, and suddenly you discover a hidden loop in the melody, a sequence of notes that repeats, drawing you in. Did you know that numbers can do that too? Take the number 1/7. When we calculate its decimal form, we get 0.142857142857. See it? That sequence, 142857. It just keeps repeating like a musical echo. But it gets even more interesting if we multiply that repeating sequence, 142857 by 2, we get 285714. The same digits just shuffled around. Multiply it by 3, and we get 428571. By 4, it's 571428. It's like a mathematical magic trick. The digits dance and rearrange themselves, but the underlying pattern remains. This concept of repeating sequences isn't just a mathematical curiosity, it actually has real-world applications. Think about music editing software, where loops form the backbone of many a track, or in electronic music, where modular rhythms rely on these repeating patterns to build complex and evolving soundscapes. Even in genres like hip-hop, producers use loops to create the infectious beats that get us moving. From the digital realm to our very own ears, the echo line of mathematics resonates in the music we love. Now let's talk about something seemingly simple, yet profoundly powerful: zero. Often overlooked, zero is a true ghost number, felt everywhere yet seen nowhere. It's the silent conductor of our number system, the invisible hand that guides mathematical operations. Think about it, without zero, how would we write the number 10, or 100, or 1,000? Zero allows us to give value to place, to distinguish between 10 and 100, to build the very foundation of our numerical language. But its significance goes far beyond just writing numbers. Zero is essential to algebra, allowing us to solve equations and unlock hidden relationships. It's the starting point for measuring change, the baseline from which we track growth and decay. And in some ways, zero allows us to touch infinity. Think about dividing any number by a progressively smaller number, getting closer and closer to zero. The result? An increasingly large number, stretching towards the infinite. However, just like a ghost, zero has its mischievous side. Dividing by zero is a big no-no in the math world, leading to contradictions and paradoxes. It's like asking the universe to divide something into nothing, a question that simply cannot be answered. Think of it like silence in music. Silence itself isn't a note, but it gives shape and meaning to the notes around it. A well-placed pause can be just as powerful as the loudest crescendo. Zero, like silence, reminds us that sometimes the most profound things are the ones we can't see. Finally, let's journey to the heart of the number system, a hidden city built on the foundations of prime numbers. Prime numbers, those enigmatic figures divisible only by 1 in themselves, are like the atoms of the math world. They're the fundamental building blocks from which all other numbers are made. Think of it like this. You have a big Lego structure, maybe a magnificent castle. Now, break it down to its individual pieces. Those individual pieces, the ones you can't break down any further, those are your prime numbers. Take the number 30. We can break it down into 2 times 3 times 5. 3 primes multiplied together create something new, something larger. What about 1001? It might seem like a random number, but it can be broken down into 7 times 11 times 13, a beautiful combination of primes. What makes primes truly fascinating is their unpredictability. There's no easy formula to find them, no pattern we can easily discern. They emerge from the number line like hidden treasures, challenging mathematicians for centuries. And it's precisely this unpredictable nature that makes primes so valuable. In a world increasingly reliant on data security, prime numbers are the guardians of our digital secrets. They form the backbone of cryptography, the science of encoding information, keeping our online transactions and communications safe. But it's not just about security. prime numbers also play a crucial role in generating random numbers, which are essential for everything from scientific simulations to online gaming. And even in music, the spacing of notes and the creation of scales often reflects patterns found in prime numbers. Thank you for joining me on this adventure through the hidden wonders of mathematics. We've explored the echoing patterns in decimal numbers, uncovered the silent power of zero, and journeyed to the heart of the number system, built on the foundations of prime numbers. But this is just a glimpse, a tiny taste of the incredible secrets that mathematics holds. Remember, math is not just about numbers. It's about discovering the hidden patterns and structures that shape our world. So stay curious, keep asking questions, and never stop exploring the magical world of mathematics. You never know what incredible discoveries await.